We have module for embedded system. I would discuss embedded system, very important under the VTO. VTO, VTO under VTO. We have this module for embedded system. The important things I only discuss about these things. Okay. Let's for first we have definition. Definition is will be the very important. It is a small revision. A embedded system is a microprocessor or microcontroller based system which designed to perform a specific task in a combination of both hardware and software. Like example, mobile headset, washing machine, air conditioner, automotive control unit set. And we have this is also important. If you just learn these things, you can get this embedded system definition. General computing system versus embedded system. It is a microprocessor based system, general computing system, whereas embedded system is microcontroller, where it will be the opposite of it. The computer needs a human interaction, whereas embedded system no need human interaction to perform a specific task, to perform a task. Okay. Just ignore it. It has two parts, hardware and software. It has three parts, where it includes hardware, software and firmware. It can perform many tasks. It performs specific tasks. You can see this. Computers are usually bigger in size, larger hardware input and output device attached. Embedded system is smaller in size, the computers with limited hardware. Power consumption is high, power consumption is low. Classification of embedded system. It is based on generation, based on complexity, performance, determination, behavior, based on triggering. Based on generation. First generation. The earlier first generation embedded system was built around 8 bits and 4 bit, 8-bit microprocessor and 4-bit microcontroller. Such as embedded system possess simple hardware firmware development using assemble code. Okay, second generation. After the evolution of second generation embedded system, 8-bit processor, 4-bit controller replaced with 16-bit microprocessor and 8-bit microcontroller. सी 8 to 16 हो गया ये तो. They are most powerful, complex compared to previous generation. This is also very important. Okay, and now we have third generation embedded system built around high performance 32-bit microprocessor and 16-bit microcontroller. It operation has become more powerful and complex. The second generation, during the period of domain specific digital signals process, DSP applications. A fourth generation embedded system built around on chips, reconfiguration process and multi-core process. Emerging embedded market add more powerful performance. The system makes high performance real-time operation system and their operations. Just reference. This is also quite important. Based on complexity and performance required, small scale embedded system, medium scale, uh, and a large, hold on, large scale embedded system. This is the many very important. It is one of the repeated, not most repeated. We have system core, communication interference, output and input. Other supporting integrated circuit systems. System core, memory. This is firmware, where we are discussing about embedded system, right? Firmware. This is the firmware. Let's starts from memory, input output, communication interference, and other supporting integrated circuiting systems. This is a basic explanation of this. You just read once. The major application area of embedded system: consumer electronics, household applications, home automatic securities, home automated industry, telecom, computer repairs, computer networking system, healthcare like X-ray, CCD, and measurement instruments, banking related automata like ATM, currency counter, card reader. And now we have the core system, the core of embedded system: microprocessor, microcontroller, and digital signal process. This is also very important. You have to learn this. Microprocessor, microcontroller, we have around three difference between. We have to learn three, no, the three also thoroughly, so that you can score marks. Consider a CPU consists of CPU perform arithmetic and logical operator. High intensity chips containing CPU, RAM, ROM. It's like mainly based on CPU thing. It is mainly used for personal computers. It is mainly used in embedded system. A complex, expensive, high, large number of instrument into process. Depends unit, self-contains units. Consumer more power, consumes less power. Consumes more power. Limited power saving option. It's lot of power saving features. Architecture is based on one normal model. Architecture is based on hardware architecture or something. Now RISC a reduced instrument set computer, a software center design. Like this is the one of the important, you have to learn this. RISC, whereas full form is reduced instruction set computer, complex instruction set computers. A software center design, hardware center design. Low power consumption, high power consumption. Required more RAM, required minimum amount of RAM. Simple decoding instruction, complex decoding instruction. Process high pipeline, and it is not pipeline in less pipeline. Extension time is very less, extension time is high. Uses multiple registration, uses single registration. It does not require external memory calculation, it required external memory calculation. This is there and this is not, this is not, this is there. It's micro architecture. It won't be asked. Just ignore it and never ask these things. Instrumentation and control system, it is also very important. You have to learn this. Physical quantity, where sensor, single conditioning, display, signal processing, data output, recording. It is very important. Like you have to learn physical quantity, sensor, signal conducting, signal processing, display, recording, display recording. Like physical quantity, sensor, signal conducting, and data output. Where we have this input, or this is like comparator, error signals, energy, power amplification, control device, output. Signal condensing sensor, you have to learn this. Just once you see sensor and actuator, it is a physical quantity in electronic signals. It converts electrical signals into physical. It takes input from environment. It take input from electric and electronic system. Sensor generate electric signals. Accurate generate heat, motion, vibration. It plays input port of system, it plays output port of system. It uses measuring the physical quantity. It uses measuring continuous and distinct process parameters. Okay, you have to learn just once you just have a look at it. Sensor is a transistor which converts energy from physical electrical from any measurements. Control purpose, sensor acts input device. We have to write professional words so that okay, just ignore these things, it won't be asked. Light emitting diode, it is bit important, but let's not focus, just have a look on it. It's 7 segment LED, which is the most repeated and asked question. Like it is very easy. 7 segment displays an output device displaying alphanumerical 0 to 9 and A to F character. It consists of LED segments In special output LED segments, 7 is used display alphanumerical character. The LED segments need A to G and decimal point LED. A segment A is named the DP LED segment. Is just explaining about how it is used. You can see A, B, C, D, E, F. There is a G. I will show. Hold on. G. Okay, is there A, B, C, D? Just remember and explain in the professional words as how it comes. And common anode and common cathode, like it goes upwards anode or downwards cathode. We have to write like this. This is DP called as decimal point, where we can decimal point in short form we can should write DP. P2 7654321 we have to write this ulta microcontroller like based system, and we have to give a truth table. It is very important. Okay, I'll show you this bit code. It's okay not to write, but if you can remember, just write it. One for one, what are the things that will be blinked? Like A will be 1, B, where you see B 0, C 0. There is no other things like D, E, F, so it is 1 1 1 1 1. Are you able to understand? I will give another example like 5. What are the things like blinked? A 0, A 0, B 1, like B also 1 not blinked. B, C is blinked, so it is like 0 0. C, D, E is not blinked, so E will not be 0, it will be 1. And then F will be blinked, so 0. Like that it goes on. Hope this is understand. It's a small revision type.